Good morning, folks.
Hello.
Hey, Radek. Will I be able to have you go over some of the Crimson performance tests that you guys have been doing?
Uh, well, in short, two random read scenarios have been verified. One with large chunk for M, second one with 4K. For large chunks, which I hope are not so important, at least at the beginning of the project, well, we are significantly slower. But when it comes to small chunks, well, there is substantial difference. In my testing is based on the code from Tuesday, and I'm on Inserta. I can see around 1.5 more IOPS for 60% of CPU cycles in comparison to classical OSD. Still, it's early testing, and the Crimson OSD is at the moment very simple, and I would expect it will need to grow a bit. However, I would love to grow it only a bit, slightly, definitely not too much.
Yes, I agree. I agree. This is the same. Is this the same data that we were looking at earlier this week in stand-up?
Yes, it has been the sole difference is that I added the TMAM-based profiling, and also Kifu is working today on repeating those numbers. Well, it looks he's getting even better. He's getting even better results on 4K.
What happens? You had mentioned in here that dwarf profiling isn't working. Um, is it what goes wrong with it?
I guess it's because of the size of the stack.
Yeah.
I personally imagine the that per free cards when it comes to dwarf profiling, that it grabs just some maybe configurable amount of bytes from your stack.
Does
And then it's being processed, however, not by per free card, it's being processed at the per free port stage. That's how I imagine the entire profiling. But if the grab space is not enough to describe, to have the content for entire call chain, then, well, you are getting mess in report. However, it can be quite easily worked around it just by instructing GCC to add the frame pointer, basically
does
to keep it.
does GDB still give you useful backtraces?
I haven't tried with GDB PMP, to be honest. I would
Yeah,
expect
yeah.
that. Well, but I would expect that the GDB should be able to decode the stack properly, to unwind
Yeah.
the stack properly.
I think it uses dwarf, right? With
Yep, but I
libunwine.
guess it also has available all memory. It's not just making any small narrowed snapshots. That's when I would expect from per record that it wants to sample as much as possible with as small overhead as possible.
Yeah,
It's contrary to grabbing entire stack.
yeah,
I can imagine it only tries to grab a small portion of it.
yeah,
And in our call and in Crimson, the stack deep is extremely deep. We have we have a lot of small procedures, and well, I'm not surprised that Dwarf has failed. But I
Yeah.
also tried to profile with the LBR support of PMU, last branch record. However, on our Haswells we have in Sterta, it can record only 16 last entry, only 16 entries. It's not enough, I'm afraid.
Oh, this is very cool, Radic.
But still, please take it with a grain of salt.
Oh, yeah.
It's very early. We had even to fix to alter the Turing machine to even be able to run the benchmark. From profile, it seems we are doing the real job, but it's extremely early testing.
Oh, yeah. Yeah. Absolutely. It's just fun to actually see it, accomplish something, right?
Yep. And since Tuesday we got some improvements. If we implement, if we added the usage of our caches for object info, and I'm reviewing the big pull request from Inxin for the Crimson Messenger. The nice thing it does is that we are batching. We started batching our TX messages. When it comes to send, we are doing batching right in the PR. That's quite promising stuff, because from profiling I can see that we are bottlenecked at the CPU's front end. We are taking a lot of L1 instruction cache misses, and also a lot of early branch mispredictions.
Yeah.
In Intel, I guess it's related to the branch address calculator. In the Intel's TMEM methodology, we are not seeing too much bad speculations. We are not seeing a few pipe slots wasted because of bad speculation. Now it's mostly because of CPU's front end. We are front end bound.
So Radic, what we have now is this running in a single thread?
Yes, it's one thread only.
Cool. And are we benchmarking with DPDK or with the kernel's network stack?
Kernel's network.
Okay, thanks.
And so right now, within one thread, you're able to pull off like 21,000 IOPS on reads, like random reads.
21, it's for classical OSD.
Oh, that's classical OSD. Okay.
For Crimson, it was, if I recall correctly, 32,000. But we burned 60% of CPU cycles, and we have plenty of room for optimization. Kifu is getting around 2 times more IOPS for half of the CPU usage.
So that was 34,000 read IOPS you got just from one core, though, right?
Yes.
That seems really good. I don't have anything I can pull up easily quickly right now, but I imagine you were burning more than one core on that classical test, right?
Yes, that's correct.
Yeah.
Between 1.5 to 2 cores.
Yeah. That's good. That's really good. Like you said, it's simple right now. There's more stuff that will get added in.
It is.
Yeah.
Yep. I would expect we'll need to grow it a bit, but Well, I believe that usually that simplicity goes together with performance. Usually, of course,
Yeah,
not always, unfortunately.
agreed. Cool. Well, that's exciting. Thank you for going over that.
So where you're talking about CPU usage in the Crimson OSD, like C star is just gonna spin when it's idle anyway, right? So is that really the
Exactly. Even if we do nothing, I would expect to see one core burned.
right? Okay.
All right. Well, let's see. I wasn't sure if we were going to be able to get Sage today or not, but maybe I'll just quick go over some of the pull requests here then. Not a whole lot new. I think everybody's still working on kind of stuff related to Nautilus and bugs and things, but there's one here that I actually didn't add in because it's not really performance, but I just moved the priority cache management code out of BlueStore into the priority cache namespace, um, into some kind of like little manager thing. So the goal with that is that we want to do the same thing for the other daemons that we kind of did for the OSD, have automatic memory tuning so that they try to stay within a certain bounds, and then kind of balance out the priority of memory for different caches, assuming that they even have different caches. But it's fairly generic, so it could be used if it's useful. So that a PR for that just appeared this morning, and Sage put it in his testing branch. We've got uh, someone that's going to go through and work on that. Let's see, other stuff this week. Well, Crimson Performance work that Kifu's got. There's this make delete range optional on a number of keys. Casey, you commented on that. Are you looking at that? Have you reviewed it?
Um, I did scan it and it looks great. I basically just commented saying that it looks really useful for log trimming stuff that I've been looking at.
Cool.
But I don't know the specifics of RocksDB and the problems that we've had with range deletes in the past. So I don't know if RocksDB has addressed the issues there or if we're still kind of geared to use it.
Yeah, I remember having the discussion, but I don't remember any what the problems were. So, um, yeah. Radek, do you remember? Were you involved in the range delete? Yeah.
I don't think so.
Okay. Well, anyway.
Something about performance for the ranged tombstones versus normal tombstones.
Yeah, I saw the comment in the pull request about it. I don't remember that being what I thought it was, but
Well,
yeah, I
I
don't
think
know.
it was just you talked to them, Mark, but my recollection is the Rocksdb tool, from what you relayed, is that the Rocksdb tool said it just wasn't stable and they weren't sure if it was ever going to work completely.
Oh,
So we should ask them, right?
sure. Yeah. Yeah. Yeah, I couldn't remember what it was that was making it problematic, but Greg, you probably have a better memory than I do. So, okay, well, yeah, someone should verify with them then that this is a good idea.
But yeah, this PR is just adding another option to the code paths there. If we're not using those by default, then I see no reason not to take this.
Cool. All right. One PR this week closed out of the list of stuff here. I think this was just a bunch of random things that were useful. And it looks like Eric merged that. So he's not here, but looks good. What else? Updated stuff, more Crimson. Uh, there was an update and discussion around the write around cache policy from Jason. That looks really exciting. That combined with his like IO scheduler stuff. He talked about it yesterday in the monthly meeting, developer meeting. So if you're interested in that, watch the recording because it sounds really good. I'm excited about it. Let's see. Oh, some of the work on the auto tuning the MDS cache memory limit. So we're gonna try to get that running on top of the new PR I just submitted this morning. And then Radic, I saw you added do not merge to this bounding code optimization thing. What's going on with that?
It's because of the incompliance of the size method of std list. It seems we'll need to take care about that for a much longer time. It's not well. I plan to dissect this one commit from this PR and just remove the DNM, so it will be reduced. Significantly reduced. But well, it gives really slight bonus. It's not so important, to be honest.
Sure. All right. I think that's it for updated stuff this week. Still have a bunch of stuff in no movement. Any news, Adam, on your stuff?
I am currently trying to get one thing through testing, but it is being held up by testing not working properly.
Understood. I've been there. All right. Yeah, I guess that's probably about it. So, discussion topics. Radic already went over the Crimson stuff. That's really exciting. I'm very encouraged by the numbers that they're seeing out of the gate, given that it was just the first attempt. And it sounds like things are improving really quickly, so that's great. Let's see. Oh, Igor has been working on RocksDB read ahead stuff and doing some of his own code inside BlueStore. He saw really weird test results, but the gist of it is that his code is working well, it seems, based on what he told me. They had a situation where they were very much affected by iterator read ahead, and his code was, I think, reducing it from like 2 minutes to 39 seconds, and then trying to use the new RocksDB iterator read ahead, it was like taking more than 10 minutes, but he thinks that maybe the test wasn't right or something. So he's still working on it, but lots of work going on in that area, which is good. Oh, Igor, you're here. I'm sorry. Go ahead. You can talk about it better than I can.
Mute. Mark, you were absolutely right about and summarizing what I have so far. Nothing to add.
Okay. All right. Well, then the only other thing that I have got is that we wanted to look at BlueStore compression because no one, as far as I know, no one has really looked at it real closely. So this past week, I ran through some tests, very, very basic, not doing any kind of real fine tuning of it, just looking at what happens with a standard FIO workload that's somewhat compressible and turning aggressive compression on versus having it off. And so that's in the Google Doc there. The gist of it is that especially with like large writes, it's quite a bit slower, especially when you're CPU limited. There's one case that's kind of interesting for small sequential reads where it appeared to actually improve them. I don't know why, but that's what happened. This is probably really much more complex than the seemingly simple configuration change really makes it look like, right? Because there's an initial prefill that happens before I run these tests, and then I run them in order from large IOs down to small IOs, doing the different workloads. And so potentially you could end up with initially all of the data compressed, but then some of the rewritten data maybe is not compressed. When you're reading it, it's hard to know what's going on, what's what. BlueStore, the way that the compression works is that it may decide not to compress things if it doesn't think it's going to be able to compress them well. And you have thresholds for that, and you have lots of other settings. So it's really, in reality, quite complicated. But overall, in general here, the performance was, ranging from mildly worse to quite a bit worse. So I'm not sure it's something that most users are going to want to use in its current state. But we'll see. When I get time, I'm going to try to run it through some profiling and see if it's anything stupid that would be easy to improve. So that's about it. Oh, go ahead.
Mark, a couple of comments about sequential reading. I think you are getting a sort of read ahead this way, because to decompress the blob, it reads more than your read request size, and it gets into the cache, and hence it doesn't need to read it next time.
That is a very good insight. I bet you're right. Well, maybe we need that. Maybe that's a sign that read ahead in BlueStore would be a good idea, right?
Well, for reading that small chunks, maybe.
And this was kernel RBD, so you'd expect that you'd be getting client-side read ahead, but I suppose I don't know. Huh. But yeah, that's a good thought, Igor. But anyway, so that's that. When I get time, I'll try to look into it more. But other things are cropping up, so not sure how much time I'll have to revisit some of this stuff.
And well, as far as I understand, you are performing these tests one by one without resetting your store.
Correct. So
I suggest to, well, maybe to run differently and, well, init the store each time before the next series of tests.
Yeah.
Because previous runs might change the data layout and have plenty of overlapped blobs there. So
yeah, I think the question is always with that the balance of what's the reasonable way to run the tests, right? Because like you said, that would probably be much more repeatable.
Yeah, they are much more predictable, I'd say. So maybe some more advanced tests should mix these scenarios, but as a first stage, I'd suggest to pre-fill the storage time you are getting series of runs.
Even as you go through, like, even if you did like a pre-fill stage, which is, we do this, so this one you do pre-fill and then do a bunch of tests, right? But even there, you could imagine that if you do pre-fill and then start doing a bunch of random writes, the performance throughout the course of the test will change, right?
Right. So,
you can't even that.
General rule would be to pre-fill each time after some random write scenario.
Yeah, do the pre-fill, then maybe do a bunch of random writes for like, I don't know, 30 minutes or something, whatever, or until you've rewritten the entire thing maybe, and then do the tests after that. Ugh.
Well, maybe
But anyway,
it depends on what's the purpose of this benchmark. So
yeah,
yeah.
exactly. Well, I think the purpose initially was just to say, well, how bad is it or how good is it? All right. Well, so that's all I've got, guys. Any other topics folks would like to bring up this week?
So back to the subject of RocksDB and delete range. I did some Googling and it looks like there have been some updates late last year. And it sounds like they've resolved the performance issues. So that would be interesting to investigate further.
Okay.
I shared a couple links with you on Ceph Mark.
Oh, fantastic. Thank you. All right. I will look at those. Actually, speaking of RocksDB, I don't know how many people are aware, but Toshiba just released their own fork, I guess, of RocksDB that's really, really interesting. I don't know if this made it out to Cephdevel or not, but let me link. This is the code base.
P-Rock stuff? Oh, yeah.
Yeah. So the idea here is that they are only putting the keys in the LSM, not the data. And so it reduces write amp significantly if you have large values in the database.
Isn't it kind of like the whiskey stuff? I thought the whiskey was doing something similar.
I don't remember who it was. There's something that I think this is like based on, but I don't remember if it was their stuff or not. Could be. There's a wiki or something out here too. Let me get it. But this looks really, really, really good. Because even in their own test results, they're showing that the compaction overhead, when you get like big compactions due to deep leveling, it's way faster or way less overhead at the very least. So for us, this could be like almost a drop-in replacement, maybe that would alleviate some of those issues that people are seeing. Or at least that's what I hope. Maybe it won't, but
That's the dream.
yeah, exactly. So Adam's also working on the sharding, the RocksDB sharding, which one of the kind of goals of that is almost the same thing where we're just trying to avoid the deep nested level hierarchies by spreading the data across multiple shards and maybe only ending up in like level 2 rather than potentially ending up in maybe level 4 or something, and then have lower write amp because of it. But this also have concurrently could make things significantly better. So I think we're hoping that we'll be able to run some tests with this. And again, it's just basically the normal RocksDB code base. So it might just be a drop-in replacement. So we're looking at that. If anyone is interested in playing around with it, by all means.
That is very cool. I know that Matt is still interested in database stuff for IGW, so I'll make sure that he stays in the loop.
Cool. All right. All right. Well, yes, that's it for me. Anything else, guys? All right. Well, have a good week, everyone. See you next week.
Bye.
See you. Bye.
Thanks, Mark.